We find math in every aspect of our lives today, from the GPS that delivers us to the front door, to the digital communications that we have with our relatives across the world, to our banking to make sure that our transactions are secure. Waterloo may very well be the most mathematical city in the world. With the Faculty of Mathematics having 250 lecturers and professors and 8,000 students, that's an incredible concentration of mathematical talent. We include all subjects from computer science, data science, artificial intelligence, through to the various aspects of pure and applied mathematics.
With over 200 professors, that allows us to have a breadth of research topics and also depth, because there are people who normally would be isolated because they work on very specialized topics, but here they have other people to work with.
My research is in optimization techniques applied to machine learning. The goal is, it's called unsupervised learning in my case. We learn the hidden structure in a problem. We're learning what's called a Bayesian network. It's really, you set it up as an optimization problem. There's really wonderful applications being built right now. As we all know, we can talk to our computers now and they actually understand us in many cases. In industry is very excited by these applications, but also there's nonprofits and government and non-government organizations. There's a lot of problems in the world that can be solved using AI techniques, or at least improved using AI techniques. So there's wonderful opportunities there to make the world a better place. And then I should also acknowledge that the AI could come with a real cost. Society needs to address the benefits, but also plan for the major disruptions that could happen with AI.
It's really exciting to be doing crypto research here at the University of Waterloo, because there's so many people involved and so many different perspectives. We've got the threat of quantum computers and the work being done in the Institute for Quantum Computing. We've got the new work of the Cybersecurity and Privacy Institute taking a broad perspective on security, and then the detailed work on cryptography by the Center for Applied Cryptographic Research. So it's really great to be at a place where there's so many people so directly focused on security and cryptography. The impact of my research in cryptography will be to provide insight and understanding for people designing internet communication protocols and software. We'll be able to give them feedback that allows them to design more secure systems that are hopefully more resistant to attacks from malicious parties.
Interdisciplinary research in medicine, in fact in all areas of society, is crucial, because if you look at the biology and biomedical sciences, they are sciences that are sort of encyclopedic in nature. But mathematics provides the sort of rational guidance, and quite often to investigate mechanisms or underlying processes, it's not enough just to have the data and the information. In the case of cancer, we use methods from dynamical systems which have been developed to take into account Darwin's theory of evolution, so it's sort of generally known as evolutionary dynamics, the theory of partial differential equations, which is a crucial component in much of our work. And of course, with many of the modern developments, machine learning and deep learning form an integral part in analyzing a lot of the data. The use of mathematics allows you, in a sense, to provide both explanatory and predictive power. So if you can predict how something is going to evolve, then you have a much better chance of stopping it.
The policy of the University of Waterloo that researchers and graduate students, everybody own their own intellectual property, really encourage creativity and innovation in a way that is really putting actions rather than just words. And I think it creates this climate where people feel like this is the direction the university wants to go into, and I think it has given tremendous results over the whole existence of this university. The University of Waterloo has been invited to be part of the E4She campaign from the United Nations, and because of this there's been many initiatives on campus to help female students, especially in the STEM discipline. There are scholarships that are given now to entering female students. In the Faculty of Mathematics, every female graduate student at the doctoral level gets a $5,000 entrance scholarship. And we have some of our outreach groups have been working very hard to incite young girls in elementary school, even in high school, to think about math and computer science as a possible field of study, and it's been successful over the last few years.
The world is more mathematical today than has been at any time in the past, and is becoming even more so. In order for Canada to have its place in the world, and indeed for any nation to be an integral part of tomorrow's society, they have to have a full range of mathematical skills, people, and research results. I like to think of the University of Waterloo as the beating heart that drives the lifeblood of mathematical talent into Canada and throughout the world.
Audio Jungle.